With descriptive statistics, two important characteristics are the kurtosis and skewness of the distribution. Kurtosis has to do with the height or flatness of the distribution. Skewness has to do with the symmetry of the distribution.
SPSS can calculate the mathematical values of skewness and kurtosis for you. The data set we're going to use for this illustration contains 4,000 cases. If you calculated skewness and kurtosis by hand, it would take you quite a while.
Here's a partial view of the data set. Notice we're in data view. We have 4,000 cases. These are middle school students who have completed the fitnessgram testing. And we have data on their grades, whether or not they were, what their pacer laps were, what their pacer healthy fitness zone score was, and so forth.
If you went to the right on the screen, you'd find many other variables. We are only going to calculate the skewness and kurtosis for 3 of them. So here are the instructions. On the main SPSS toolbar, you click on Analyze, Descriptives, Statistics, and then on Descriptives. This will open up a box called Descriptives. And what we're going to do here is move the variables of height, weight, and curl-ups into the variable list on the right. Those are the 3 variables for which we're going to calculate skewness and kurtosis, and actually any other descriptive statistics that you want to do. Click on the Options button in the upper right-hand corner of the Descriptives box to open the Descriptives Options box. Here you can check whatever statistics you want, but be sure to include kurtosis and skewness. Now you click Continue and click on OK.
Your output would look something like this. Notice that we have descriptive statistics on our 3 variables of interest, height, weight, and curl-ups. Notice we indicated there were 4,000 cases, but some cases had missing data, so we have 3,986 people for whom we have height. You look across and you'll see we have the mean for each one, the standard deviation for each one, and then measures of skewness and kurtosis. And as you'll learn, the measure of skewness has to do with how far it deviates from a normal distribution. So for example, height is normally distributed, weight is positively skewed, and curl-up is fairly normally distributed.
For kurtosis, the statistic deals with the height or flatness of the curve. For height, it's slightly leptokurtic, but not very much. Weight, on the other hand, is very leptokurtic. Curl-up have a negative kurtosis score, meaning that they are flatter than a normal curve.
Again, notice there was some missing data for each one of the variables. And again, you can interpret the skewness and kurtosis based upon values that are provided for you in the text. So let's graph some of these characteristics and see what they look like. Here's the SPSS graph for height. Notice it's fairly normally distributed.
Next, we'll have the graph for weight, and you'll notice that the tail of this curve goes off to the right, so we would call this a positive skew. This corresponds with the number that we saw on the previous slide.
And then the last one is a graph of the curl-up scores, and notice how flat the curl-up scores are. It does seem to be symmetrical, but it's platykurtic. Now let's illustrate this for you with a smaller data set with about 3,000 cases, and we will show you with SPSS how to create what we've just done here. Now here's the data view for our reduced sample size of about 3,000 cases. So let's do the same analysis on these variables. So if we want to first look at descriptive statistics.
Let's go to the SPSS toolbar and click on Analyze, Descriptive Statistics, and Descriptives. Now that opens up our Descriptives box. So move the variables of height, weight, and curl-up into the variable list on the right. Click on the Options button in the upper right-hand corner of the Descriptives box to open up the Descriptives option box. Here we're going to click on kurtosis and skewness, and we're going to eliminate minimum and maximum. We're going to click on Continue and OK. Here are the results.
Somewhat similar to what we had with the 4,000 cases, basically showing that height is normally distributed, weight is positively skewed, and curl-up is normally distributed, but platykurtic.
So let's take a look at the graph for the height scores just to see if it looks like it's normally distributed.
We go to Graphs, Legacy Dialogues, histogram, and we'll take the height variable and we'll put it in the variable box. We'll also click on this little box where it says display normal curve, and we'll say OK. Notice here's the graph of the height scores for over 3,000 people. Are they normally distributed? Certainly appear to be. You could do the same thing then for any other variable to illustrate whether it's positively skewed, negatively skewed, normal, or what the kurtosis of the variable looks like.